Hi everyone, welcome to the Chapter 22 notes. If you're looking for them and having trouble, I gave you a packet of notes that had Chapter 6 stapled on top of Chapter 22. So if you just page through those, you should be able to find where I'm at right now. Chapter 22 covers two categorical variables, the chi-square test, and we've already actually done the chi-square GOF goodness of fit test because it's a little easier to get started on. But actually our textbook covers what's called a test of independence first. So let me back up. In chapter 20, we spent a lot of time comparing proportions of successes for two groups, and that's probably what your project is addressing. Is there a difference in the probability between freshmen doing something versus seniors, say? You're really limited there. You can have two groups, you can have freshmen and seniors, but your outcome is very limited. There's only success or failure and nothing in between. So I think, a lot of times in class we'll say, what proportion of people like cheese? That's kind of our go-to proportion. Well, there's probably in betweens. There's people who really like cheese and kind of like cheese and don't like cheese at all. We can't really get to that level of detail when we're working with just a two proportion test. But with chi-square, we can start to investigate those ideas. We can have two or more groups. We can have freshmen, sophomores, juniors, and seniors. We could have four groups if we wanted to. And we can have more than one outcome. We can have love cheese, like cheese, indifferent towards cheese, dislikes cheese, for example. What we'll be doing in this kind of chi-square test, a test for independence, we'll be trying to figure out if, say, liking cheese is independent of age, or if age is somehow related to liking cheese. To get started on that process, you will use a two-way table, which is why we started with Chapter 6 and talked about marginal distributions versus conditional distributions. So as you saw, we put the number of observations falling into each combination of the two categorical variables into a cell of the table. And then we played around with percents from the counts in the table. We're going to look at the counts in the table, compare them to what percents that we would have expected if there was no relationship, and decide whether the probability is such that we're willing to reject a null hypothesis that there's no relationship between two things. Okay, our null hypothesis is going to be there's no relationship between these two categories or ideas. And the alternative will be that there is a relationship, that one affects the other. So take a look at our intro problem here. We've got a company that makes computer keyboards that has developed two new letter arrangements for computer keyboards. The company wishes to see if there is any relationship between the arrangement of letters on the keyboard and the number of hours it takes a new typing student to learn to type. And we'll say 20 words per minute speed is learning to type. It assigns beginning typist to one of three keyboards. There's A, there's B, or there's the standard keyboard that we've been working with all our lives, which is the QWERTY keyboard. QWERTY for the first line across any keyboard. Okay, so we've got a table of the observed counts. The title of our table is Keyboard versus Time to Learn to Type at 20 words per minute. It will be important to know how many rows and how many columns are in your table. Now, rows, you're going to count down this way. This is a row with the A, this is a row with the B, standard is a row. There are 3 rows. Okay, so 1, 2, 3. Columns, well, there's 21 to 40 hours for learning to type. There's 41 to 60 hours, and there's 61 to 80 hours. So actually, there's also 3 columns. Okay. Now, if you look, the counts are here, but the row total and the column total are not. Okay, the marginal counts, if you will, are not given. So let's fill those in. Okay, our row total if you look here for keyboard A, we had 25 hours, or 25 that were between 21 and 40 hours, 30 between 41 and 60, 25 between 61 and 80. That's 80 typists got assigned to keyboard A. If you add 30, 71, and 19, you'll see that we have 120 typists assigned to keyboard B. And then you'll notice 35, 49, and 16 add to 100. There were 100 typists assigned to the standard QWERTY keyboard. You also want to know the column totals. The column totals will tell you how the breakdown for time worked. If you add these up, we get 90. There's 90 typists who took between 21 and 40 hours to learn. There were 150 typists that took between 41 and 60 hours to learn. There were 60 typists, if you add these up, that took between 61 and 80 hours to learn. Okay. What we'll need to do to run a chi-square test for independence is figure out the expected frequency for each cell. Okay. What we have here is the actual frequency. Okay, the observed. What happened in real life is summarized in the table. But we are comparing to an idea that there is no relationship between the keyboard and the times learned to type. So we need to know what the expected frequency would be in that case. So think about expected frequency as a probability. Let's look at, say, this cell here. Okay, let's look at cell 2. What's the probability that a typist fell in that category? That a typist was assigned to keyboard A and took 21 to 40 hours to master 20 words per minute. Okay, if you think back to probability rules from like Algebra 2, and I think we reviewed them a little bit in the fall. A probability for keyboard A, well, there were 80 people assigned to keyboard A, right? 80 people assigned to keyboard A. And then how many were there total? We actually haven't put that on our table yet. We added our row totals, we added our column totals, but we didn't actually add those numbers up. Add this up, say, or add these up. If you notice, they should add up to the same thing, right? 300 people participated in this experiment. So that's going to be my denominator for my first probability. The probability that you were assigned to keyboard A was 80 out of 100. Okay. What about the probability that you were assigned, or that you took 21 to 40 hours to master 20 words per minute? Well, that would be, let's see, 90 people over 300 in the sample. Okay. So we have two probabilities, but they're separate probabilities. If you recall, when you want to find the probability of two things happening, this and that, we actually multiply. So we would have to do, let's see, 80 over 300 times 90 over 300. Okay, you have to remember how to multiply your fractions. So we could reduce this to, say, 4/15 times 3/10 and do some cross canceling. Let's see, 2 and 5, and we get 2/25. Okay, there's a 2/25 probability with a sample of 300 that a typist was assigned to keyboard A and took 21 to 40 hours to master it. Master typing, that is. As far as an expected count, we would take the 2/25 and we'd multiply it by 300 people in the sample to figure out how many should be in that cell, or how many we would expect to see in that cell. Okay, let's see, 25 goes into 300, let's see, 4 times in 100, so 12 times, so 2 times 12 is 24. We would expect 24 in that cell, okay, if there was no relationship between the two. We see that there's 25, so off, but not by much, okay. What chi-square is going to do, as you've seen before, is we're going to add up these differences. And the larger our chi-square statistic, the less probable it is that there's no relationship between these two things. Okay, now this is annoying, it takes a long time, so how can we make it go faster? Well, there's a formula. If you look on the next page, E for expected here is going to equal the row total times the column total. We're using the marginal counts here. The row total times the column total divided by the sample size will give you expected. Okay, so I'll do one with you. And we've already done this one, but we'll see it again. So I'll do this cell with you. 80 times 90, okay, the row total for this row times the column total divided by the sample size, which is 300. And as we already saw, when you calculate that, compute that, you get 24. Okay, let's do the next one. Let's change colors here. So this cell, our row total for this cell, if you go down here, is 80, okay, which was the same as last one, but now we're in this column, and if you see this column, 150 is our column total. We divide that by 300, and when you do, you get 40. Okay. I'll pick another cell, right in green here. I'll pick this cell. Okay. For this cell, our row total is 120. Our column total is 60. When we divide by 300, we actually get 24 again. Okay. So what I'd like you to do right now is go ahead and fill this chart in. Okay. Complete filling this in. And I will actually go to another video because YouTube limits me to 15 minutes to complete the rest of the notes. We're going to do the next 2 pages as well. So fill this chart in using our new formula and then start the second video that I'll also have sent in a link to you.